Hello everybody, welcome to Mathskpreet. Hope you all are doing fine. So we were doing chapter number 1, real numbers of grade 10th from NCERT. So far we have seen the result for fundamental theorem of arithmetic along with its proof and related examples and few questions from exercise 1.1. In today's lesson, I'll be teaching you the next theorem related questions and exercise 1.2. In most of the questions, we have to prove a number to be an irrational. By making use of the result of these two theorems, we'll see the proofs for such questions where we have to show them irrational. So the result for the fundamental theorem of arithmetic was saying that every composite number can be expressed as the product of primes, and this representation is always unique apart from the order of the factors. So the next theorem is saying that let p be a prime number, and if p divides a square, then p divides a, where a belongs to positive integers. Fine, capital Z means integers and Z with plus here means positive integers. So we'll make use of the result of the fundamental theorem of arithmetic while proving the result of this theorem. P divides a square, then P will divide a for positive integer a and any prime p. Here we have in the proof a is a positive integer such that this is sign belongs to a belongs to positive integers such that we can write this a as the product of the prime. So these are the factors for this number a. So I have written all the pi's are primes, may not be distinct, they may repeat. Fine. So to write a square, I'll multiply these factors 2 times. So in the second bracket, we'll write the same factors. So a square means we can multiply these factors. So we'll get square of these primes. Fine. So now we have as p divides a square. According to the theorem, this thing we have p divides a square. That means that is, or we can write it as p divides a square. We have p as a factor of a square. We all know that when a number is dividing another number, that means this number is automatically be a factor of that number. So p is a factor of a square. Fine. If p is a factor of a square, these are all the possible factors of a square. Then by fundamental theorem of arithmetic, what I am having, p is a factor of a square, these are all the possible factors of a square, then p will be a value from p1 square, p2 square, p3 square and so on, pn square. This is the result of fundamental theorem that every composite number can be expressed as the product of primes. So these are the factors of a square. P is also a factor of a square. Automatically through this theorem, P will be a value from these factors. But here we will use the uniqueness concept of that theorem. But by using the uniqueness result of fundamental theorem of arithmetic, we can write that this p will be a value from which values p1, p2, p3 so on pn. We will skip these squares to write the uniqueness here. So then by using the uniqueness result of fundamental theorem of arithmetic, we have p is a value from p1, p2, p3 so on pn. This was the thing that uniqueness is giving us. Fine. So if p is a value from these pi's, then these pi's are what? These are factors of a. This you can mark it number 1. From number 1, p is a value from the factors of a. If p is a value from the factors of a, this means that basically p is a factor of a. If p is a factor of a, then we can write p, therefore P will divide A. That is, P will divide A. Hence proved. So I hope you understood the proof for the theorem. Here in this step we have applied the result that every number can be expressed as the product of primes, and here by using the uniqueness we just skipped these squares. We will just take the values of the primes only, not of the square or not of the values that are square of these primes. Just the primes we will take from the uniqueness here. Fine. So I hope you understood. Let's see the related questions. So this is question number 1, where we have to show that root 5 is an irrational number. So before that we must know the definitions for rationals and irrationals. So what a rational number is. So a number of the form, suppose P by Q, where Q should not be equals to 0 and P and Q are from integers. One more thing you can add to this definition. I used to give this definition only while explaining what are rational numbers. So here you can write the GCD of P and Q must be 1. This is the complete definition for any number to be a rational number. So here P by Q, if the satisfying all these conditions, then this belongs to rational numbers. Fine. So what are irrational numbers? Numbers that are not rationals, or we can say real numbers minus the rational numbers will get the irrational numbers. And the notation for the irrationals is what? Capital P. So we have seen the results in 9th standard that on operating a rational, this is the operation say, with irrational we will always get an irrational number. This operation could be plus, minus, multiplication and division. Out of these 4 operations, if we are taking any operations on a rational and irrational number, one is rational and second number is irrational, then result will always be an irrational numbers. These things we have seen in standard 9. So to prove such questions we will assume the thing, and in the end we will contradict that thing and we will get the result that we have to prove. This is known as proof by contradiction. So here we will assume the opposite. Assume that root 5 is a rational number. If root 5 is a rational number, then this can be expressed as P by Q. What is P and what is Q? P belongs to Z, Q belongs to Z. These are integers. Q is not equals to 0, and what else? GCD of P and Q. Greatest common divisor or the highest common factor of P and Q is 1. Fine. Cross multiplying these we will get Q root 5 is equals to P. Squaring on both sides, on squaring both sides, we get what we are getting. Q square 5 is equals to P square. Q square 5 is equals to P square means that 5 is dividing P square. Fine. Suppose if I have, this can be written as 2 into 18. This means that 2 is dividing 36 as well as 18 is dividing 36. This thing I have done here. This was my number and these are the factors. From here I need to take 5 according to the requirement, but here also Q square is dividing P square as well as 5 is dividing P square. Here I have written 2 is dividing 36, 18 is dividing 36. So I can write Q square divides P square, 5 divides P square. So I am writing here according to the requirement 5 is dividing P square. So if 5 is dividing P square, then by making use of the result of the last theorem we just proved, we can write it as 5 will divide P then. So if 5 is dividing P, we can write this P as 5 into A. Fine. Why? Because this is a factor, this is a multiple. We can write this multiple as 5 into some more factor. So on squaring both sides, again on squaring both sides, I am getting P square is equals to 5A whole square means 25A square. Put the value of this P square from here as Q square 5 is equals to 25A square. I am writing here again what I am having right now, q square 5 is equals to 25 a square. So what I can cancel out 5 here. So q square is equals to 5a square. Fine. This means that if I am getting this equation, this is giving me 5 is a factor of q square. Fine. If 5 is a factor of q square, then by making use of the last theorem, I can write 5 will divide q as well. Fine. Now what I have, 5 is dividing p, 5 is dividing q. That means you can write it number 1 and number 2. From 1 and 2, what I am having, 5 is dividing p, 5 is dividing q. This implies that 5 is a factor of both p and q. If 5 is a factor of both p and q, that means 5 is a common factor of p and q. So in the beginning, as we have assumed this is a rational number, then by the definition of the rational numbers, these two numbers are having 1 as common factor, but here what I am getting, 5 as the common factor of these two integers, which is contradicting the definition of the rationals. Therefore, here we can write which is a contradiction to our assumption. Fine. So this is contradicting the thing that we have assumed. That means we have assumed root 5 is a rational. This thing is wrong here. This thing we have proved wrong here. Therefore, root 5 is not a rational number. Fine. If this is not a rational number, what else it is? Therefore, it is an irrational number. Therefore, root 5 is an irrational number, hence proved. Why? Because real numbers have two types of numbers. One is rational. If not rational, the number will be irrational number. Fine. Let's see one more question. Prove that root 7 is an irrational number. Same steps, same procedure we will repeat to prove the question. Okay, let's see the proof again. We will assume root 7 is a rational number. If this is a rational number, then according to the definition, root 7 can be written as p by q, where p comma q are belonging to integers. Q is not equals to 0 and GCD of p and q is equals to 1. I am just giving you single step for the two steps given in the book. You can write directly in the definition of rationals this GCD step and you will get one step reduced to prove the result. So if now we have root 7 is equals to p by q. On cross multiplying, what I am getting, q root 7 is equals to p. On squaring both sides, what I am getting, this. On squaring both sides. Okay. So if q square 7 is equals to p square, this is giving me what? 7 is a factor of p square. This further is giving me 7 is a factor of p square, means 7 divides p square will give me 7 will divide p from result of last theorem I am writing. Okay, you have to write complete result here. So if 7 is dividing p, that means p can be written as 7 into some more factor. Why? Because p is a multiple. So on squaring both sides again, what I will get, p square is equals to 49a square. Fine. What is the value of p square? From here you can write it number 1. So p square is equals to q square 7 is equals to 49a square by using 1. By using 1 I am writing this. Now on cancelling, what I am getting, let me write here. On cancelling I am getting q square is equals to 7a square. I am just cancelling this 7 from here. So q square is equals to 7a square. This will give me 7 will divide q square. Again from the result of the last theorem, I will get 7 will divide this q as well. So if 7 is dividing q and 7 is dividing p, mark this number 2 and number 3. Here you will write the reason of the theorem. So from 2 and 3, what I am getting, 7 is dividing p, 7 is dividing q. That means, therefore, 7 is a common factor of p and q. So in the beginning, according to the definition of the rationals, the common factor between P and Q was 1, but here what I am getting, the common factor is 7, which is not possible. So this is contradicting our assumption that root 7 is a rational number. So you can write which is contradicting our assumption. Which is contradicting our assumption. Therefore, root 7 is an irrational number. Proved. This is how we have to prove these questions. I hope you understood. The next question is prove that this number is irrational. So again we will assume this number as rational. Okay. So if this is rational, this can be written in the form of P by Q. What are P and Q? These are from integers. Q should not be equals to 0 and GCD of P and Q is equals to 1. So this can be written as 2 root 5. I'll take this 3 on the right hand side. It will become of minus. Now this root 5 can be written as P by Q minus 3 divided by 2. This can be written as P minus 3Q divided by 2Q. Fine. So ultimately what I am having, root 5 is equals to P minus 3 root Q dividing by 2 root Q. This is what the value of root 5. But we all know that this root 5 is what? This is prime here. This root 5 is what? Irrational number. So if you are getting this question for the higher marks, you have to prove how this root 5 is irrational number. Otherwise you can directly write, as we know, root 5 is an irrational number. Therefore this value is what? This is also an irrational value or number. If this is an irrational number, then ultimately what it's giving us, this is contradicting our assumption that this number is what? Rational. So to show this belongs to P or irrational number, we'll assume 1 by root 2 belongs to Q. So 1 by root 2 will be of the form P by Q, where P and Q are what? Integers. Q should not be equals to 0 and GCD of P and Q is 1 here. So this root 2 can be written as Q by P. So we all know that this value is what? An irrational number. With the same method we can write all the steps to prove this as irrational. So if this is irrational, this is, we can write, but root 2 belongs to P means irrational numbers. Fine. Root 2 is an irrational number, therefore it is contradicting assumption number 1. You can mark it number 1. So this is contradicting assumption number 1. Therefore root 2 is, therefore 1 by root 2 is irrational. So these were few questions from exercise 1.2. Very simple, very easy. These questions were, if you know how to prove the root value of some prime number to be irrational, then you will be able to prove such types of questions to be an irrational number. I hope you understood each and every step of the solutions of the questions and proof of the theorem. In the next videos, we will see the next chapters from the grade 10th. Till then, study hard, take care. If you're liking my videos, you can share it as well. Hit like if you like and subscribe for more. And thank you for watching. Have a good day.